Hello, this video is going to provide a little tutorial of our ANOVA Excel calculator. And you can see we've got an example here of a one-way ANOVA. It says a researcher is interested in the effect type of residence on personal happiness of college students. She selects samples of students who live in campus dorms, off-campus apartments, and at home, and asks the respondents to rate their level of happiness on a scale of 1, meaning not happy, all the way up to 10, meaning happy. So these are the scores for the students living in the dorms. You see 8, 9, 7, 8. There's 4 students in the dorms, 4 students in the apartments, and 4 students at home. And in the column next to those are the squared scores, which we'll need momentarily. Okay, so if we come down, in order to calculate an ANOVA, we need the sum of scores, the sum of squared scores, the sample size, what's called the grand mean, which is really just the mean of all the groups combined, the sum of squares total within and between, and the degrees of freedom within and between, and the mean squares within and between. So there's a lot here. All of that is just to give us an F score, which we will compare to a critical value taken from the F distribution table, which you can see I've included that here for easy reference. So if you look at these individual calculations here, you'll notice up here it shows a formula, and this may be a little small for you to see on your screen, but you can see if I click in this box, it highlights the relevant cells from the Excel document that are being used in that particular formula. So as the sum of scores, all we're doing is we're taking the sum of the 4 students in each of these different living arrangements and adding up their scores. So adding them all together gives us 57, right? 32 plus 9 plus 16. But we also need the sum of the squared scores, and that's what this column was for. And similarly, you can see that what we're doing there is just adding up those 3 sum totals for each group of the squared scores. We need that to give us some of the other calculations below. Okay, you can see down here where those show up. So we have the total sample size. So there's 3 groups, 4 students in each group. So combine that and you'll get 12. And so the grand mean is the sum of scores, which we have right there. So that's, if I click up here, you'll see it's the sum of scores divided by the sample size gives us the grand mean. Again, the grand mean is just the mean for everybody combined, not the separate groups, because each group has its own individual mean, but the grand mean is for everybody. Sum of squares total is indicated here. You can see it's the sum of squared scores, which we got up here, minus the total sample size times the grand mean squared. So these cell references, in this case we have B13 minus B14 times B15, and then the caret sign tells Excel it's an exponent, and then 2, the exponent is 2, it's a square. Okay, so that's just translating what it says here into an Excel formula using the data here. Sum of squares within, you can see there's the formula there, so it's a sum of squares scores. Again, that's this here, 347, and then minus, in this case now we're looking at the individual sample sizes times the individual means added together, right? So n1 times x1 mean squared plus n2 times x2 mean squared plus n3 times x3 mean squared. Again, if I click up here, you'll see the relevant boxes are all highlighted for the formula. And the nice thing about using these cell references instead of just typing in numbers is I can change the values and it will automatically update the scores down here. So I can use this table for other problems, although I might need to adjust a few things, and I'll talk about that momentarily. Let's finish going down these cells. So the degrees of freedom between is just the number of groups minus 1. So we have 3 groups here, so that's 3 minus 1 is 2. Degrees of freedom within is the overall sample size, which is 12, minus the number of groups, which is 3, so that gives us 9. Then the mean squares is the sum of squares within divided by the degrees of freedom within. And we've already calculated those. So it's 6.75 divided by 9. Okay, and that gives us 0.75. And then the mean squares between is the sum of squares between divided by the degrees of freedom between. So once again, in this case, 69.2 divided by 2. Okay, and that'll give us 34.75. And then finally we get to the f-score, which is the mean square within divided by the mean square between 0.75 divided by 34.75. And so we get 46.3. And what we're comparing that to is the critical value. So at the F table, we have degrees of freedom of 2 and 9, right, for between and within. So on the F table, you go to 2, and then you come down to 9. You see 5.71. And you can see 46 is clearly larger than that. So statistical conclusion is to reject the null of no difference between the groups. So happiness levels, the substantive conclusion is that happiness levels do differ by residence type. And you can see just looking at the scores that, for instance, dorm scores are 7, 8, 9. Apartment scores are 1, 2s, and 3s. So very clearly those are low happiness scores. These are very happy ones. The people at home are somewhere in between the 5, 4s, and 3s. Okay, so we do have statistical evidence here that happiness levels do differ by group type. So let's say you want to use this calculator to make your own one-way ANOVA for a different type of problem. So if you right-click on this sheet, you see an option is to move or copy. Right? So if you create a copy, it will make another one. You can see it has a number 2 there. And you're going to want to give that a different name probably, but we'll just leave it as it is. And now we're ready to add a different problem here, change the basis of the grouping, and perhaps the number of rows, so the number of cases in each group might differ. For instance, maybe we have to insert a row because there's 5 in each group. So now let's change that. And the other thing you'll have to check is to make sure that these formulas down here, if you do wind up changing the number of rows, or even more tricky is adding groups. So let's say we wanted to add a group 4. So let's just change the name of these, group 1, group 2, group 3, and group 4, and then x4 squared. Right, so that's how we start. Found included in the boxing here, you just highlight these cells, click Format Cells, and then go to the border, and that will, if you add the outline in the inside, it'll add it to the table. Let's just put in some values here for the sake of, whoops, I was doing that all wrong. There we go, 4, there you go. Oops, probably don't want something that large. 8 and 9. Okay, so now we have sample sizes of 5. So let's go ahead and update those. Okay, now the grand mean, let's change that to a formula. Here we had the value. Let's make that a formula. That will, if you click auto sum, you can now just select. Whoops. Let's see here what I do. Okay, so equals. well, let's just type it sum and then open parenthesis. Then we'll click on the, if you hold down the control button, you can select multiple cells at the same time. So we're just adding those things together to give us a total sample size there. So that's 20. The grand mean, okay, so the sum of scores is now going to be different also because it was only adding together these, and now we have to add another sum. First, let's calculate the rest of this. So if you highlight one of these squared things, you can then paste it over here. It'll automatically update the cell references. Okay, and so now we have our squared values. Then we can also grab one of these and copy the sums for the columns and copy and paste those in. And we can also copy and paste the mean. Okay. So the sum of scores, again, we'll have to update that by, if we hold down control, we can add the new group. So we have group 4 now. No, something was off there. Well, we'll just manually add it in. So plus, and you can see this is H10. There we go. Some of the squared scores also needs to be updated now because it doesn't have that one. So we have to add I10 to complete that. This one we've already updated. Right? These references are off now because we'd have to add a 4, but we won't bother with that for now. So the grand mean should be updated now. Yep, since we have the correct sample size and sum of scores. Sum of squares total should also now be accurate because we have updated those things. Sum of squares within, so you can tell we don't have the terms for group 4 here. So if you go into this formula, you can see we need to add another term. So what we're looking for is column H. So it's going to be H9 times H11 squared. All right, and you see it highlighted those new cells as we wanted. So now the sum of squares within is accurate. You can see the sum of squares between also needs updating because it is not highlighting the last, what we have here, the H column. So what we're going for with this one we need to add the mean for the fourth group squared minus the sample size times the grand mean. Okay, that's what each term is doing. It's the mean squared, sample for the group. Okay. Okay, so we need to add right there H9 times H11 squared. Whoops, squared. There we go. And this is all one term. then this is the grand mean. Okay, so that if we highlight that, it should all, yeah, now we're seeing these highlighted as well as those, and as well as the grand mean. All right. Now the degrees of freedom, we now have four groups, so it's 4 minus 1, which is going to be 3. And within, the sample size is now 20. 20 minus 4 is 16. You can see that's automatically updated, so the mean square scores we don't require any changes to the formula for that. And the F score is also automatically updated to include what we've got there. And I've added some more values just to balance this table. And there we get our result. We can see critical value you're going to have to change for F because we now have different degrees of freedom, 3 and 16. So between is 3 and 16, so 4.08 is going to be the new critical value. All right, so that's how we would adjust this. Now we also have a problem where we have two variances. I'm going to delete that. Whoops, I changed the wrong one. Now we also have a problem here where we're comparing variances. So this problem says, are the variances for incomes on the east and west coast the same? Suppose the table shows the results of a study. Income is shown in thousands of dollars. Assume that both distributions are normal and use significance level of 0.05. Okay, so we have our scores here. So this is the East Coast. 38 means 38,000. 47, $47,000. Okay, so we have those. Now what I've done is I've taken these scores and I've calculated a mean. Okay, so that's 63,250 is the average salary on the East Coast. Over here is the West Coast, and you can see the average is higher at 73,000. Then I created this deviation column. So it's this score minus the mean, right? So 38 minus 63.25. Okay, if I highlight that, you can see it's B4 minus B14. I use the cell references. And then this same thing here. And then this column are the squared deviations, so we're just taking that and squaring it. So in this case, C4 squared. And then so on. Each of these is the same, the square of the deviation. Then we take the sum of all the squared deviations and the mean, right? So the average squared deviation is actually the variance. Okay, so that's a little note right there. The variance is the mean of the squared deviation. So we're comparing this number, the variance for the East Coast. We're comparing that to the variance for the West Coast. All right, so that's 801. And the degrees of freedom is the sample size minus 1. So we actually have 8 in the sample for the East Coast, so 8 minus 1 is 7. And the West Coast, we have 7 in the sample. 7 minus 1 is 6. So we have 7 and 6. To get our critical value, we need to go to the F table and look at 7 and 6. You see it's 5.82. It's off a little bit. Let's fix that. Okay. And so the calculated F value is up here. And you can see it's just simply taking this variance and putting it in the numerator, and this variance putting it in the denominator. So it's a lot simpler to do the F test when comparing variances than it is over here when we're dealing with means, right? Because you have to do, it's quite a bit more involved with this calculation. Um, so the result of this test, the critical value of 5.8 is much larger than the calculated F value of 0.82, so we fail to reject the null of equal variances. So basically what that means is income variance does not differ between the east and west coast. All right, so for your information, I have included what's called a two-way ANOVA just to show you what's involved in that calculation. So I'll allow you to just look at that on your own, but basically we don't just have two groups, we have two layers of groups. So for this problem, we're comparing two authors uh, by different degree types. All right, so again, I'll let you read this on your own and kind of click on these cells on your own also so you can sort of see how this is all calculated. Ultimately, we have to calculate 3 F scores and compare them to 3 critical values down here. So just very involved. And this is a special kind of line graph showing the differences for the authors by degree type and the scores they get from the grad students. You'll see what I mean when you read it. All right, that's it. Thanks.